This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hey, this is Jeremy Jung for Software Engineering Radio. Today I'm talking to Scott Hanselman. He's a partner program manager at Microsoft, the host of over 750 episodes of the Hansel Minutes podcast, and he's got a YouTube channel. He's got a lot of interesting videos. One of the series I really enjoy is one called Computer Stuff They Didn't Teach You. You're all over the place. Scott, welcome to Software Engineering Radio.
Thank you for having me. Yeah, I was an adjunct professor for a while, and I realized that in all of my career choices and all of my volunteerism and outreach, it's just me trying to get back to teaching. So I just started a TikTok. So I'm like the old man on TikTok now, but it's turned out to be really great. And I've got to engage with a bunch of people that I would never have found on any other social platform. So whether you find me on my podcast, my blog, which is almost 20 years old now, my YouTube or my TikTok or my Twitter, it's pretty much the same person. I'm a professional enthusiast. But that's all done in the spare time because my primary job is to own Community for Visual Studio.
That experience of being a teacher in so many ways is one of the big reasons why I wanted to have you on today, because I think in the videos and things you put out, you do a really good job of explaining concepts and just making them approachable. So I thought today we could talk a little bit about .NET and what that ecosystem is. Because I think there's a lot of people who they know .NET is a thing, they know it exists, but they don't really know what that means. So maybe you could start with defining like what is .NET?
Sure. Microsoft is historically not awesome at naming stuff. And I joke about the idea that 20 years ago, Microsoft took over a top-level domain, right? Thereby destroying my entire .org plan to take over the world. When they made the name .NET, they were coming out of COM and C and C++ involved component object models, and they had made a new runtime while Java was doing its thing in a new language and a new family of languages. And then they gave it a blanket name. So while Java was one language on one runtime, which allowed us to get very clear and fairly understandable acronyms like JRE, Java Runtime Environment, and JDK, Microsoft came out of the gate with here's .NET and C# and VB and COBOL.NET and this and that. And this is a multi-language runtime. In fact, they called it a CLR, a common language runtime. So rather than saying, here's C#, it's a thing, they said, here's .NET, and it can run any one of N number of languages. Now, the reality is that if you look over time, Java ended up being kind of a more generic runtime, and people run all kinds of languages on the Java runtime. .NET now has C#, which I think is arguably first among equals as its language, although we also have VB and F#, as well as a number of niche languages. But the .NET larger envelope name as a marketing thing remains confusing. If they had just simply said, hey, there's a thing called C#, it probably would have cleared things up. So, yeah, sorry, that was a bit of a long answer, and it didn't actually get to the real answer. Bear with me.
So, I mean, you had mentioned how there was this runtime that C# runs on top of. Is that the same as the JVM, like the Java Virtual Machine?
Right. So as with any VM, whether it be V8 or the JVM, when you take C# and you compile it to an intermediate language. We call it IL. Java folks would call it a bytecode. And it's basically a processor non-specific assembler, for lack of another word. If you looked at the code, you would see things like load 4-byte string into, pseudo register type of stuff. And you would not be able to identify that this came from C#. It would just look like this kind of middle place between apples and apple juice. It's kind of applesauce. It's pre-chewed, but not all the way. And then what's interesting about C# is that when you compile it into a DLL, a dynamic link library, which is like a shared object, or you compile it into an executable, the executable contains that IL, but the executable doesn't know the processor it's going to run on. That's super interesting because that means then I could go over to an ARM processor or an Intel x86 or an x64 or whatever, an iPhone, theoretically, And then there's that last moment. And then that jitter, that just-in-time compiler, goes and takes it the last mile. That local runtime, in this case, the CLR, the Common Language Runtime, takes that IL, chews it finally up into apple juice, and then does the processor-specific optimizations that it needs to do. Now, this is an oversimplification because the pipeline is quite long and pretty exquisite, in fact. For example, if you're on varying levels of processor on varying versions of x64 or on an AMD versus on an Intel machine, there's all kinds of optimizations you can do, as well as switches that we can do as developers in config files to give hints about a particular machine. Is this a server machine? Is this a client machine? Is it memory constrained? Does it have 64 processors? Can we prep this stuff both with a naive JIT, a naive just-in-time compilation, or then over time literally learning over the runtime cycle of the process and go, I bet you we could optimize this better, then swap out while it's running a new implementation. So we can actually do a multi-layered JIT. So here's I want to start my application fast and run this for loop. This for loop's been running for a couple of thousand milliseconds and it's kind of not awesome. I bet you we can do better. Then we do a second pass, swap out the function table, drop a new one in, and now we're going even faster. So our jitter, particularly our 64-bit jitter, is really quite extraordinary in that respect.
That's pretty interesting because I think a question that a lot of people might have is what's the reason for having this intermediary language and not compiling straight to machine code? And what it sounds like what you're saying is that it can actually at runtime figure out how can I run things more efficiently based on what's being executed in the program.
Right. So when you are running a strongly typed language that has the benefits and the speed of a strongly typed language, and you also choose to compile it to a processor-specific representation, we usually, as developers and deployers, think about things in terms of architectures. Like, this is for an ARM processor, but is this a Raspberry Pi? Is it an Android device? Do you really want to get down to the stepping individual versions of, like in Intel? For example, I'm talking to you right now on an Intel i9, but it's a desktop class processor that was the first one released many, many years ago. It doesn't have the same instruction set as a modern i9 or a Xeon or something like that. So we have to be able to know what instruction sets are available and do the right thing. And then if you add in things like SIMD for doing, data parallelization as the CPU level, if that's available, we might treat a vector of floats differently than we would on another thing. So how much information up front do we know about deployment? And is it worth doing all that work on the developer's machine? And this is the important part, which may not necessarily reflect the reality of where it's going to get deployed. My desktop does not represent a machine in Azure or Heroku or AWS. So getting up to the point where we know as much as we can, and then letting the runtime environment adapt to the true representation of what's happening on the final machine. That doesn't mean that we can't go and do native compilation or what's called NGen or native image generation if we know a whole lot, but it provides a lot of value if we wait until the end.
Yeah, that's an interesting point too, in that if we are compiling down to an intermediate language on our own development machines, then we don't have to worry about having all these different targets, right? Of saying, I'm going to build for this specific type of ARM processor, all these different places that our application could possibly go because the runtime is taking care of that for us.
Right. And I think it's one of those things where it's taking care of it for us unless we choose to. It reminds me of the time, if you remember, when we went from mostly manual shift cars to automatic shift cars, but people who bought fancy Audis and BMWs were like, when I'm going to the shops to get groceries, I'm cool with automatic, but I really like the ability to downshift. And then we started to see these hybrid cars that had, D and R for drive and reverse, and then a little move left and move right to take control. And I'm going to tell the automatic, transmission on this car that I really want to run at a higher RPMs. .NET tries to do that. It gives you both the ability to just say, do what you're going to do. I trust the defaults, but then a ton of switches if you choose to really know about that ending environment.
We've been talking about the common language runtime, which I believe you said is the equivalent of the Java virtual machine. You also mentioned how there are languages that are built to target the intermediate language that runtime uses, like C# and VB and things like that. And you touched on this earlier before, but I feel like we haven't quite defined what .NET really is. Like, is it that runtime and so on? Yeah.
Okay. My apologies. Yeah. Okay. So .NET is an all-encompassing marketing term, I would say, is the ecosystem, just as Java is a language and also an ecosystem. So when someone says, I know .NET, I would assume that they are at the very least familiar with C#. They know how to compile code and deploy code. They might be able to be a website maker, or they might be an iPhone developer. That's where .NET starts getting complicated. Because it is an ecosystem, someone could work, let's say two people could work for 10 years in the ecosystem, and one could be entirely microservices and containers on the back end in the cloud, and the other person could be Android and Unity and games and Xbox. And they are both .NET developers, except they never touched each other's environment. One is entirely a game and mobile app developer, and the other one is entirely a backend developer. That's where it's harder. Now, I think the same thing is true in the Java world, although I would argue that you'd be surprised how many places that you can find .NET, whether it be in a Python notebook, you can run .NET and C# and an IPYMB in a notebook in Jupyter, on the Google Cloud, or you can run it on a microcontroller, not a microprocessor, but literally on a tiny 256K microcontroller. All of that is .NET. Now, .NET is also somewhat unique amongst ecosystems in that it has a very large, what we call BCL, the base class library. One of the examples might be that, with a Python or with a JavaScript, you say console.log, hello world. We get the same thing. And then it's like, hey, I need a really highly optimized vector of floats with a complicated math processing. Well, you have to go and figure out which one of those libraries you want to pull in, right? There's lots of options in the Python world. There's lots of options in the Java world, in the JavaScript world. But then you have to go hunting for the right library. You have to start thinking. Microsoft, I think, is somewhat more prescriptive in that our base class library, the stuff that's included by default, has everything from regular expressions to math to representations of memory, all the way up to putting buttons on the screen. So you don't always have to go out to the third party until it's time to get into higher level abstractions. And that has made .NET historically attractive to enterprises, because when you're picking a framework and it has a whole ton of ecosystem things, who do you throttle when it doesn't work, right? There's an old joke that people picked IBM because it gave them one throat to choke. People who are in enterprises typically will buy a Microsoft thing, and then they'll buy a support license, and then they can call Microsoft when it doesn't work. Now, in the fast forward 20 years, Microsoft has a balance between a strong base class library and a rich open source environment. So it's a little bit more complicated, but the historical context behind why Microsoft ended up in enterprises is because of that base class library and all of those libraries that were available out of the box.
And that's sort of in direct contrast to something like, say, JavaScript, where people are used to going to the Node package manager and getting a whole bunch of different dependencies that have been developed by other people. It sounds like with .NET, the philosophy is more that Microsoft is going to give you most of what you'll need, and you can sort of stay in that environment.
I would say that was the original philosophy. I would say that was pre-open source Microsoft, so maybe 10, 15 years ago. I would think that is not a philosophy that is very conducive to a healthy open source ecosystem. But it was early on when it was like, here's a thing you kind of buy. You didn't really buy it, but like it comes with Windows and you buy Visual Studio. When I joined about 13, 14 years ago, myself and others started really pushing open source because we came from the open source community. And as we started introducing things like Azure and services, .NET is free, has been free, is now open source. Visual Studio Code, Visual Studio Community are all free. So the stuff I work on, I actually have nothing to sell. As such, it's better to have a healthy community. So we have things like NuGet. So NuGet, N-U-G-E-T, is the same as NPM, is the same as Maven. It's our package manager environment. And that is allows you to pull both Microsoft libraries and third-party libraries. And we want to encourage an open source community that then, pays open source framework creators for their work, uses things like GitHub sponsors. People who are working in enterprises now need to understand that if you pick just the stuff that Microsoft gives you out of the box, you may be limited in the diversity of cool stuff that's happening. But if you go and start using open source technology, you might need to go and pay a support contract for those different tools or frameworks, depending on whether it's a reimagination of ASP.NET, our web framework, and you say, I don't like the one Microsoft has. I'm going to use this one. Or an OAuth identity server that Microsoft does not ship out of the box. It's a missing piece, therefore use this third-party identity server.
What are some things that you or Microsoft has done to encourage people to build open source stuff for .NET?
Well, early on, Microsoft was, attempted to open source .NET by creating a thing called Rotor, R-O-T-O-R, which was a way of saying, hey, Java, everyone in academia is using Java. We have one too, but it didn't exist. The only real open source licenses at the time were GPL. So Microsoft made a very awkward, this is about 20 years ago, very awkward overture where it's like, here's a zip file with a weird license that Microsoft made called the MSPL, the Microsoft Permissive License. And here's a kind of a neutered version of .NET that you could potentially use. And it wasn't open source, it was source opened. It's like, here's a zip file, like go play with this. There were no takebacks. Fundamentally, Microsoft was not a member of the open source community. They were just like, hey, look, we have one too. When we started creating ASP.NET MVC, the model view controller stuff, which is kind of the Ruby on Rails for .NET, the decision was made by a bunch of folks on the team that I worked on and encouraged by me and others who think like me, just open source the thing and do takebacks. It's not just, hey, you can watch us write code and do nothing about it, but the takebacks is so important. The rise of GitHub and social coding enabled that even more. So now actually about 60% of .NET comes from outside Microsoft. It is truly collaborative. Now, Microsoft used to patent a bunch of stuff. They'd patent stuff all over the place, and everyone would be worried, I don't want to commit to this because it might be patented. But then they made the patent promise to say that any of the patents that cover .NET won't be things that will be enforced. And then they donated .NET to the .NET Foundation, which is a third-party foundation, much like many other open source foundations. And .NET and all of the things within it, the logos and the code and the copyrights are all owned by that. So if Microsoft, God forbid, were to disappear or stop caring about .NET, it is the communities that can be built and deployed and run entirely outside of .NET. So it's overtures like that to try to make sure that people understand that this isn't going anywhere. It's truly open source. And then takebacks is such a big thing. And this has been going on now for many, many years. Most people who think .NET, and probably the folks that are listening to this show, are thinking the big giant enterprise monolith that only runs on Windows that came out in the early 2000s. Now it is a lightweight, cross-platform, open source framework that runs in containers and a dozen Linuxes and Raspberry Pis. It's totally open, and it's totally open source all the way down. The compiler's open source, all the libraries, everything.
To your point of people picturing .NET being closed source, running only on Windows, I think an important component to that is the fact that there have been multiple .NET runtimes, right? There's been the framework, there's been Core, there's been Mono. I wonder if you could elaborate a little bit on what each of those are and what role they fit in today.
That is a very, very astute and important observation. So if I were to take Java bytecode, I've taken Java source code and I've turned it into Java bytecode. There are multiple Java runtimes, Java VMs that one could call upon. There's ones from Oracle, there's Zeus, and there's different open source, open JVMs and whatnot. There are even interpreters. You can run that through a whole series of them. There's like, you can imagine a pie chart of all the different Java VMs that are available. Now, certainly there's the 80% case, but there are lots of other ones. The same thing applied in the .NET ecosystem. There is the .NET framework that shipped and ships continually still with Windows. And the .NET framework and its associated CLR, I would say, is and I'm putting my fingers in quotes here, a .NET. But to your point, there are multiple .NETs, plural. Mono is a really interesting one because it is an open source, clean room re-implementation of the original Windows-based .NET. And clean room in that they did not look at the source code. They looked at the interface. So if I said to you, Jeremy, here's the interface for system.string, write me an implementation of this interface. Here are the unit tests. And you wrote yourself a Jeremy specific system.string, and it worked. It passed all the tests. Now, who knows, under load, it might behave differently, but for the most part, you made a clean room re-implementation of that. Mono did that for all of .NET proper. But then that became a new .NET. So for those that are listening, they can't see us or see a screencast, but imagine that I go out to the command line, and with a Microsoft implementation of .NET, I make a new console app. It says console.writeline. Then I compile it into an executable. I can then run that with Mono. So I created it on one environment and I ran it with another. So I did the compilation and the first bit of chewing, and then finally the jitter would run through Mono, because the IL language is itself a standard that has been submitted to the standards organizations, and it is a thing. So if you and I were advanced computer science students in university, that might be an interesting homework assignment. Write a IL interpreter, or write an IL jitter. And if you can successfully consume IL that has been created by one of these many .NETs, you have passed the course. Then .NET Core is a complete re-implementation, open source, cross-platform with no specific ties to Windows. And that's the .NET that is we're hoping will be rebranded just .NET. So 5 years from now, people won't think about .NET Core or .NET Framework. They'll just think about .NET. It will run great on Windows. It'll run great on Linux. It'll run great in the cloud, yada, yada, yada. That is a a third .NET. We're trying to unify all of those with the release of .NET 5, which just came out. And .NET 5, we picked the number because it's greater than 4, which was the last version of .NET on Windows. But we also skipped a number because .NET Core 3 would have been confusing if we named it .NET Core 4. Again, Microsoft not being good at naming stuff. You imagine two lines heading to the right, .NET Framework and .NET Core. They then converge into one .NET. The idea being to have one CLR, one common language runtime, one set of compilers, and one base class library, so that if someone were to learn that, if we hearken back to the middle of the beginning of our conversation when I said that there was a theoretical .NET developer out there who's a gamer, and there's another one who's doing back-end work, they should be using the same libraries. They should be using the same languages. They should have a familiarity with everything up to, but not including the implementation-specific details of their systems, so that if a Unity person or decides to become a back-end developer, or a back-end developer decides to move over to make iPhone games, they're going to say, oh, this is all the system.this and that stuff I'm familiar with. That's a system.string. I appreciate that, as opposed to picking an iPhone or an Android specific implementation of a library.
If .NET Core is the open source re-implementation of the .NET framework, and you were talking about how Mono is this clean room implementation of it, what role does Mono play currently?
Mm-hmm. Good question. So Mono was originally created by Miguel de Icaza and the folks that were trying to actually make an Outlook competitor on Linux. That then turned into the Xamarin company, Xarium. And Xamarin then was a different re-implementation, which allowed them to do interesting stuff like, can we take that IL and send it over to doing a thing called SGen and generating code that would run on an iPhone or code that would run on an Android? And they created a whole mobile ecosystem, and then Microsoft bought them. So then, because Mono and .NET work on the same team, we're getting together right now and we're actively merging those together. Now, originally, Mono was really well known that it was just nice, solid, clean C code. You could basically clone the repo, run configure, run make, and it would build. While the Windows implementation of .NET Core and .NET Core in general wasn't super easy to build. It wasn't just a clone, configure, and make. A lot of work has been done to make the best parts of Mono be the best parts of .NET Core, as opposed to like disassembling one and taking them apart and making this Franken build. We want to make it so .NET Core is a reimagining of both the original .NET Framework on Windows and the best of a cross-platform one. So that is currently in the process in that .NET 5, .NET 6 wave. So this year, in November, we will release .NET 6, and that will also be an LTS, or a long-term support release. So those of you who are familiar with Ubuntu's concept of LTS, those long-term support versions will have, many years, 3 years plus of support. And by then, the Mono .NET merge will kind of be complete. And then you'll find that .NET Core will basically run everywhere that Mono would. That doesn't mean Mono as an ecosystem goes away. It just becomes another, not the supported version of .NET at a runtime level.
When we look at the Java virtual machine and we look at that ecosystem, there are languages like Scala and Clojure, things that were not made by the creator of the JVM, but are new languages that target that runtime. And I wonder, from your perspective, why there was never that sort of community with the common language runtime.
I would think that because the interest from academia early on 20 years ago was primarily around Java, and Microsoft was slow on the uptake from an open source perspective, that slowed down possible implementations of other languages. And then .NET got so popular and C# evolved, because C# is now on version 9. The C# that you wrote, the idiomatic C# of 2001, is not the idiomatic C# with includes, records and async and await and interesting things that have shown up on C# and then been borrowed by other languages, async and await being a great example, LINQ, language integrated query, being another, things that didn't exist. That language has evolved fast enough that people didn't feel that it was worth the effort. And it was really F# that picked an entirely different philosophy in the functional way by doing kind of an OCaml style thing. And because C# and F# are so different from each other, they really fit nicely. They're as different as English and another language that isn't Latin-based, and that meaning that they add flavor to the environment. That doesn't mean that there aren't going to continue to be niche languages, but there was also things like Iron Ruby and Iron Python, but they weren't really needed because the Python and Ruby runtimes already worked quite well.
We've been talking about .NET and sort of the parts that make up .NET, but I was wondering, other languages have niches, right? You have Go maybe for more systems type programming, or Python for machine learning. Like, are there niches for .NET?
Oh yeah, I mean, so I would gently push back on the idea of niche though, because I don't want to use niche as a diminutive, right? I kind of like the term domain specific, just in the sense of, when in Finland speak Finnish. That doesn't mean that we would say, hey, Finnish didn't win. Like, we're not all speaking. It's not the language that won. But we don't want to think about things like that. There are great languages that exist for a reason because people want to do different stuff with them. So, for example, a really well thought of language in the .NET space is F#. And F# is a functional language. So for people who are familiar with OCaml and Haskell and things like that, people who want to go and create a language that is, very correct, very maintainable, very clear, that has a real focus on you managing the problem domain as opposed to the details of imperative programming. It has immutable data structures by default. There's a lot more type inference than there is in C#. A lot of people use F# in the financial services industry, and it also has some interesting language features like records and discriminated unions that C# people are just now kind of getting hip to.
What I typically see, or what I think people sort of believe when they think of .NET, is they think of enterprise applications. And I'm wondering if you have some examples of things that are sort of beyond that space.
Sure. So when I think of .NET, like in the past, I would think of like big Windows apps with giant rows of tabs and text boxes over data. If I go to my eye doctor and I see the giant weird application that he's running that's multiple colors and a lot of grids and stuff, and I think, oh, that must be written in .NET. Those are the applications of 20 years ago. The other thing that I think people think about when they think about .NET is it's a thing that is tied to Windows and built on Windows and probably takes about gigabytes of space. .NET Core is meant to be more like Node and more like Go than it is to be like .NET Framework. So for example, if I were to create a microservice using .NET Core, I go out to the command line and I type .NET new web or .NET new empty or .NET new console. And then I can say .NET publish, and I can bring in a runtime. Now, we talked before about how you could keep things very non-specific until the last minute and let the runtime on the deployed machine decide. Or you could say, this is going to a Raspberry Pi. It's going to be a microservice on a Raspberry Pi. I want it to be as small as possible. So there's multiple steps. We've gone and we made this little microservice and we published it. Then we publish all of the support DLLs, the dynamic link libraries, the shared objects if it's going to Linux, all of the native bindings that provide that binding between the runtime and the native processor and the native operating system, all the system calls. Then that is right now about 150, 180 megs on .NET. But then we look at the tree of function calls and we say, this is a microservice. It only does like 6 things. It looks at the weather. It calls like 6 native functions. Then we do what's called tree trimming or tree shaking. And we give it a good shake. And then we basically delete all of the functions that are never called. And we know those things, right? We can introspect the code and we can shake this thing and we can get microservices down to 30, 40 megs. Now, again, you might say, well, compared to Go or compared to writing that in C, sure, but you're talking about still maintaining the jitter, the garbage collector, the strongly typed abilities of .NET, all of the great features of this cool environment, shaken down to, 30, 40 megs, and then you can pack that tightly into a container. Even better if the container layer above it, and if you imagine a multi-stage Docker container, doesn't include the compiler, doesn't include the SDK, and the container above it includes the runtime itself, you might only deploy 10, 15 megs. You can really pack nicely together a .NET microservice and then a whole series of them, thousands of them potentially, into something like Kubernetes. That's a very fundamentally different thing than the giant .NET application that took 2 gigs on your hard drive. This is the cool part, though. That giant, we call it Windows Forms or that WPF, that Windows presentation application, that often we find in large enterprises moves slowly because not runs slowly, but moves slowly from a DevOps perspective because the enterprise is afraid to update it or they need to wait for Windows to get the version of .NET that they want. Because .NET has historically been tied to Windows, which sucks, then that application and the whole team behind it gets depressed. What if we could take the cool benefits that I just described around containers, backport it so that that giant application at my doctor's office ships its own local copy of .NET, which it can then maintain, manage, and deal with it's on its own, all in a local folder, doesn't need to wait for Windows. That's really cool. Then they could do that pre-jitting, basically do a native image generation, and even create a single executable where inside is .NET, so that I give you mydoctorsoffice.exe, you double click on it, you install nothing, it simply unfolds like a flower into memory, including all of the benefits. Now, it's not generated native code at this point, right? It's .NET in an envelope that then blooms and then runs with all native dependencies that it needs. That is pretty cool. And that actually regenerates excitement in the enterprises so that they can bring those older applications to modern techniques like DevOps, and as well as a huge perf speedup, like 2x, 3x perf speedup.
When you talk about a perf speedup, why would including the .NET runtime with the application result in a perf speedup?
It's not that we're including the .NET runtime that caused the perf speed up. It's that 20 years of improvement in jitter, 20 years of understanding the garbage collector, rather than using the .NET that shipped with Windows, they can use the one that understands, again, a callback to the beginning, instruction sets that are newer and modern, SIMD, SSE2, all the different things that one could potentially exploit when on a newer system. Those things we get huge numbers. And actually .NET itself, .NET 5 is like 2 or 3x over .NET Core 3, which is 2 or 3x over. So a huge push has been happening. And actually all the benchmarks are public. So if you go to TechM-Power, the TechEM Power benchmarks, you can see that we're having a wonderfully fun kind of competition, a bit of a thumb war with, the Go's and the Javas and the, Groovy on Rails of the world, to the point where we're actually bumping up against the laws of physics. We can put out, 7 or 8 million requests a second. And then you notice that we all bundle at the top and .NET kind of moves within a couple of percentage of another one. And the reason is that we've saturated the network. So without a 10 gigabit network, there's literally no more bytes can be pushed. So .NET is no longer in the middle or to the far right of the long tail of the curve. We're right up against anything else, and sometimes as fast as 10x faster than things like Node.
So it sounds like going from the .NET framework to .NET Core and rebuilding that, you've been able to get these giant speed improvements. You were giving the example of a Windows desktop application and saying that you could take this that was built for the .NET framework and run it on .NET Core. I'm wondering, is that a case where somebody can just take their existing project, take their existing code, and just choose to run it? Or does there have to be some kind of conversion process?
So that's a great question. So it depends on if you're doing anything that is like super specific or weird. Like if you were a weird application then you might bump up against an edge case. The same thinking applies if you were trying to take an application cross-platform. For example, I did a tiny mini virtual machine and an operating system for an advanced class in computer science 15, 20 years ago. I was able to take that application, which was written and compiled on .NET 1.1, and move it to .NET Core and run in a container and then run on a Raspberry Pi because it was completely abstract. It was using byte arrays and list of T and kind of pretty straightforward base class library stuff. It didn't call the registry. It didn't call any Windows APIs. So I was able to take a 15-year-old app and move it in about a day. Another example, my blog, which used to run on .NET 2, my blog is over 19 years old now, has recently been ported from .NET 2 to 4, then .NET Core, and now .NET 5, runs in the cloud, in Linux, in a container, with 80% of the code the same. The stuff that isn't the same, that I had to actually consciously work around with the help of my friend Mark Downey, was, well, we called the registry. The registry is a Windows thing. It doesn't exist. So what's the implementation? Is it a JSON file now? Is it an XML file? When it runs in a container, it needs to talk to certain mapped file system things, while before it was assuming backslashes or a C colon. So implementation details need to move over. Another thing that is interesting to point out, though, is that there are primitives. There are language and runtime primitives that didn't exist before that exist now. And one of the most important one is a thing that's called span of T, span less than, uppercase T, greater than. And this is the idea of a completely new way of thinking about arbitrary continuous bits of memory. Do you want to be at a high-level language and then messing around in byte arrays? Or do you want to think about things at that higher level, but then also avoid reallocation and copying of memory around? So something very simple like some HTTP headers come in. If you're doing 7 million of these a second, this can add up, right? And it's like, well, usually we take a look at that chunk of memory and we copy it into an array, and then we start using higher level constructs to deal with that. Now I have a list of char, and then we for loop around the list of char. That's kind of gross. And then you find out that you're hitting the garbage collector a lot because you're allocating memory and you're copying stuff around. You could take that older code, update it to use span of T and represent that contiguous region of arbitrary memory differently. Rather than an array, the span can point to native memory or even memory managed on a stack, and then deal with stuff, for example, parsing or maneuvering within HTTP headers with no allocations. So a really great example, you would ask for an example of an application that you couldn't believe. VR Desktop. Are you familiar with VR Desktop as it relates to the Oculus Quest?
No.
So the Oculus Quest is the Facebook VR thing, right? And it's an Android phone on your face, and you can use it unplugged. And then people say, well, I got this Android phone on my face. I'd really like to plug it in with a USB cable and use the power of my desktop, but then I got to ship those bits across the USB and then have a client application that allows me to use it as a dumb client. You would expect an application that someone would write to do that would be written in C or C++ or something really low level. VR Desktop allows you to actually see your Windows desktop and ship those bits across the wire, across the literal wire, the USB 3, or wirelessly, is written entirely in C#. And you can use really smart memory allocation techniques. And the trick is, don't allocate any memory. And C# is more than fast enough to have less than 20 millisecond jitter on frames so that it is buttery smooth even over wireless. And I did a whole podcast on that with Guy Godin, the Canadian gentleman who wrote VR Desktop.
That's really interesting because you're talking about areas where typically when you think of a managed language like C#, you're able to use it in more environments than you might normally think of. And I also kind of wonder, you have the new Apple machines coming out. They have their ARM processors instead of the x86 processors. What is the state of .NET when targeting an ARM environment? Can somebody simply take that IL that's on one machine, bring it on to the ARM machine, and it just works?
Yep. So if you're taking over the IL, and I'm on a Windows machine, right now I'm on an x64 machine, and I go .NET New Console, and I go .NET Run, and it works on my x64 machine. Then I say .NET Publish. I can then take that library over to the Raspberry Pi or an ARM machine, say .NET Run, and because I'm saying .NET Run with the local .NET runtime, it will pick up that IL and it will just run. So I have run, using my now 19, 20-year-old blog as an example, I have run that entire blog on a Raspberry Pi unchanged. Once I had worked out the portability issues like backslashes versus forward slashes and assumptions like that. So once the underlying syscalls line up, absolutely. And we actually announced in July of 2020 that we will support .NET Core on the new Mac hardware. There are requirements for .NET and .NET Core on Apple, like ARM64 and Big Sur, that would be required to get that runtime working. But yes, the goal would be to have native processes versus Rosetta 2 processes working, and that work is happening.
We were talking about like the typical enterprise application. You've got a Windows Forms application. Is it possible for somebody with an application like that to target ARM?
So right now, there's multiple layers. So the compiler, yes. The runtime, yes. The application, yes. At the point where if I were going to run on Windows ARM, like a Surface Pro X or something like that, we would need support for, I believe, Windows Forms, WinForms, and WPF. I don't know that those are working right now, but those apps still run because just like we have the Rosetta emulator, I can emulate x86 stuff. So for example, Paint.net is a great .NET application that is basically Photoshop, but it's $4. That it runs entirely on .NET Core, and it runs just fine on a Surface Pro X in an emulated state. And I believe that the intent, of course, is to get everything running everywhere. So yeah, I would be sad if it didn't. That's a little outside my group, but the people that are working on that stuff. And by the way, the great thing about this, go and look at the GitHub issues, right? So, if you look I'm looking right now on a .NET issue 4879, where they're talking about the plan is supporting .NET Core 3 and 5 on Rosetta 2 via emulation, and .NET 6 supported in both native M1 architecture and Rosetta 2. And there's in fact a .NET runtime tracking issue that's called Support Apple Silicon. And they walk through where they're at, current status on both Mono and .NET 6. It's cool because you get to actually see what we're doing, right? Like before you had to know somebody at Microsoft and then call your friend and be like, hey, what's going on? We are literally doing the work in open on GitHub. So if the tech journalists would pay more attention to the actual commits, they would get like scoops weeks before a blog post came out because they're like, I just saw the check-in for, the Apple Silicon show up in the .NET, da-da-da.
Might get a little bit technical for the average journalist, though. One of the things that you've been talking about is how with .NET Core, you have a lot of cross-platform capabilities. I wonder from an adoption standpoint, what you've seen. Like, are there people actually running their services in Linux, in Docker, Kubernetes, that sort of thing?
Yeah. .NET, one of the things that we try to make sure that it works everywhere. So we've seen huge numbers, not only on Azure, but AWS has a very burgeoning .NET community, as well as their SDKs all work on .NET. Same with Google Cloud. We're trying to be really friendly and supportive of anyone because I want it to run everywhere. So for example, at our recent .NET Conf, which is our little virtual conference that we make, we had Kelsey Hightower from Google Cloud, like their main Google Cloud Kubernetes person, learn .NET in a weekend and then deploy to Kubernetes on Google Cloud. We're seeing a huge uptick on .NET 5, so that unified version where we took .NET Core and the .NET Framework and unified them. It's the most quickly adopted .NET ever. I mentioned before that like 60% of the commits are coming from outside the community. We're seeing big numbers. Stack Overflow has moved to .NET Core. They're actually showing their perf. Most of the games that you run are already running on .NET. If you see a Unity game, there's .NET and C# running in that. A lot of the mobile games that you're seeing. One of the other things that we're noticing is that more and more students and young people are getting involved. So we're really trying to put a lot of work into that. One of the other things that's kind of cool that we should talk about before the end is a thing called Blazor. Have you heard about that?
Yeah, maybe you could explain it to our audience.
So just like if we use Ruby on Rails as an example, and I like to use other frameworks as an example, like builds cool stuff on top of it. So it's like you pick your Ruby, whether it be JRuby or MRuby or whatever, and then you've got your framework on top of that, and then other frameworks, and then you layer and you layer and you layer. .NET has this thing called ASP.NET, Active Server Pages.NET. It's a stupid old name. You can make web APIs that are JSON and XML-based APIs. You can make standard model view controller type of environments. You can do a thing called Razor Pages, where you can basically mix and match C# and HTML. But if you want to do those higher level enterprise applications where you just don't want to learn JavaScript, we've actually taken the CLR and compiled it to WASM, WebAssembly, and we can run the CLR inside V8. So then if you actually hit F12 tools on a Blazor page, Blazor is BLAZOR, you hit F12, you go and you hit a Blazor page, you can see the DLLs, the actual dynamic link libraries coming over the wire, and then the intermediate language that we've been talking about so much on this podcast gets interpreted on the client side, which allows a whole new family of people that already know C#, like those individuals that we spoke about at the beginning. You've got someone with 10 years experience in Unity, and someone else got 10 years experience on the back end. They never got around to learning JavaScript. They can write C#, they can target the browser, and then the browser itself runs .NET, and then Blazor allows them to create SPA applications, single page applications, much like Gmail and Twitter and PWAs, progressive web apps. So one could go and create an app, and rather than an Electron kind of an app, which is using JavaScript and a whole host of tools, they can make a Blazor app, have it run natively anywhere. They can then pin it to their mobile phone or their taskbar on Windows, and they're suddenly a web developer, and it's a really great environment for those big enterprise applications or those more line of business type apps, because the data binding is just so clean. And then that back end can be anything. So Blazor is a really great environment and a pretty interesting technical achievement to get .NET itself running within the context of the browser.
Does that mean that somehow you've been able to fit the .NET Core runtime in WebAssembly? I'm trying to understand how that works. Yeah.
Mm-hmm. Yep, that's exactly right. So remember how we mentioned before that this isn't the multi-gigabyte thing that everyone is so afraid of. You basically bring down, I think it's like 15 or 20 megs, which is, a little bit big, but if you think about the homepage of The Verge, it's not that big, right? I've seen PNGs bigger than the .NET runtime. Once you bring that down, of course, if you put that on a CDN, that's handled. I think it's actually even smaller than that. It's not that big of a deal because once it's down, it's cached. And that is really the .NET Core, mono runtime running within the context of WebAssembly. And then you're just calling local browser things. But here's the cool part. Let's say you don't like any of that. Let's say I've described this whole thing. You like the application model. I want to write C#, but you don't want to download and put a lot of work into getting the local CPU and the local V8 implementation to do that. You can actually not run the .NET framework and the .NET Core, on the client side, but you can have it run on the server side. And then you open a socket between the front end and the back end. So then the events that occur on the client side get shuttled over WebSockets to a stateful server. So there's Blazor, which is client side, and then there's Blazor server, which means it can run anywhere on any device. So then it's more of a programming model thing. You still don't have to write any JavaScript because you'll be addressing the DOM, the document object model, within the browser from the server side. The messaging then goes magically over the WebSockets. You have a persistent channel bus running between the front end and the back end. So you get to choose.
Yeah, we did a show on Phoenix Live View, and it sounds like this is a very similar concept, except that you get the choice of having that run in the server or run locally in the client.
Yeah. And I think the folks on Ruby on Rails are doing similar kinds of things. It's this idea of, bringing HTML back, maybe getting a little less JavaScript heavy and really thinking about shoving around islands of markup, right? If I have a pretty basic, master detail page and I click on something and I just want to send back a card, does that really need to be a full-blown React Vue Angular application? The idea is you make a call to get some data, you ship the HTML back, and you swap out a div. So it's trying to find a balance between too much JavaScript and too many postbacks. And I think it hits a nice balance. Blazor is seeing huge pickup, particularly in people who have found JavaScript to be somewhat daunting.
I think we've been talking about things that are a little more cutting edge in terms of what's happening in the .NET ecosystem, things like WebAssembly. What else are Microsoft's priorities for the future of .NET? Are you hoping to move into some more ahead-of-time compilation environments? For example, where you need something really small that can run on IoT-type devices. What's the future of .NET from your perspective?
All of the above. If you take a look at the Microsoft .NET IoT repository in GitHub, we've got bindings for dozens and dozens and dozens of sensors and screens and things like that. We have partnerships with folks like PyTop. So if you're teaching .NET, you can go in inside of your browser in a Jupyter kind of an environment, go and communicate with actual physical hardware and call GPIO, general purpose IO, directly. We're also partnering with folks like Wilderness Labs, which has a wonderful implementation of .NET based on Mono that allows you to write straight C# on a tiny microprocessor, microcontroller, pardon me, rather than a microprocessor, and create, commercial grade applications like a thermostat running in .NET, which again takes those different people that I've mentioned before who have familiarity with the ecosystem, but maybe not familiarity with the deployment, and turns them into IoT developers. So there's a huge group of people that are thinking about stuff like that. We've also seen 60 frame a second games being written in the browser using Blazor. So we are finding that it is performant enough to go and do, we've seen Gradius and different games like that being implemented using the canvas with Blazor server running at its heart. The intent is for it to be kind of a great environment for everyone anywhere. And then if you go to the .NET website, which is at dot.net, we can actually run it in the browser and write the code and hit run. So you can learn .NET without downloading anything. And then there's also some excitement around .NET Interactive Notebooks, which allows you to use F# and C# in Jupyter Notebooks and mix and match it with different languages. You could have JavaScript, D3.js, some SVG visualizations using C# all in the browser entirely in the Jupyter Notebooks IPYMB ecosystem.
So when you talk about .NET everywhere, it's really increasing the number of domains that you can use .NET in. Like, be the person who maybe you built enterprise Windows applications before, but now you're able to take those same skills and, like you said, make a game or something like that.
Bingo. Exactly. It doesn't mean that you can't or shouldn't be a polyglot, but the idea is that there's this really great ecosystem that already exists. Why shouldn't those people be enabled to have fun anywhere?
I think that's a great note to end on. So for people who want to check out what you're up to or learn more about .NET, where should they head?
Well, they can find me just by Googling for Hanselman. Google with Bing if it makes you happy. Everything I've got is linked off of hanselman.com. And then if they're interested in learning more about .NET, they can go to, just Google for .NET and you'll find .NET.Microsoft.com. Within the download page, you'll see that we work on Mac, Linux, Docker, Windows. If you already have Visual Studio Code, just download the .NET SDK, go to the command line, type .NET New Console and open it up in Visual Studio Code. VS Code will automatically get the extensions that you need and you can start playing around. Feel free to ask me any questions. We've got a whole community section of our website, whether it be Stack Overflow or Reddit or Discord or Code Newbies or TikTok, we are there and we want to make you successful.
Very cool. Well, Scott, thank you so much for chatting with me today.
Thank you. I appreciate your very deep questions, and you clearly did your research, and I appreciate that.
This has been Jeremy Jung for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.